Okay, good afternoon. We're going to do for this worksheet 8-A5, it's mostly a review of what we did yesterday with the dot and cross and then some adding vectors as well. But there's one piece that we didn't get to yesterday, and they ask a couple questions on it. So they ask to find the angle between two vectors. So in 2 dimensions, it's relatively straightforward, like it seems to make sense. So if we have, let's say, vector B, and we just have an x and y components, and vector C, and we've got x and y components, right? Okay, and we can actually draw these two vectors. So we're going to go, this is our x component and our y component, or our I and j, right? So we go out 4 and down 8. So we're something down here, right? And that's B. And we're going to go out -5 here. So -5 and up 1, right? Can you guys see that? Yeah. Okay. And that's vector C. Okay, so 1. Okay, and what we're looking for is we're looking for the angle between the vectors. So we're looking for this angle, and the angle that they always want is the small angle. They don't want this big angle, they want the small, the one that's less than 180. So theta, the angle that we're looking for, theta is always the small angle, or less than 180, okay, between the vectors. Okay, so we'll bubble that. So that's our thinking bubble. And if we want to find this angle, all we have to do is find these angles and then figure it out, right? So we can find this angle, theta B, and we can find this angle, call that theta C. So theta B, what trig function are we going to use if we have opposite and adjacent? You got it, tangent. So we're going to do inverse tangent of opposite, which is 8/4. And when we do that, we just plug that into the calculator, we get 63.4349. So you do need a calculator for this. And then theta C is inverse tan of opposite, which is 1/5. And I don't worry about the negatives. So, and that's 11.3099. Because I have an accurate picture, I think that's more helpful than working with the negatives. It's too confusing. Okay, so what we need now, we've got this angle, and then we need to know what this angle is to be able to add those two together to get theta. So I'm going to call this angle here, this is our supplementary angle to theta B. I'm going to call that theta B2, and I'm going to call this one B1. So I just kind of added a little subscript on there. So theta B2 is now 180 minus theta B1, and so that one is 116.565. Okay, and then to find theta is equal to theta C, this part, right, this part here, plus theta B2, which is this angle here that we just figured out, was 116 B2. So we're adding this one plus this one. And when we do that, we get 127. So 127.8749 degrees. So that's the angle between the two vectors, and that would be your answer. Okay. There is also a really cool formula for this. So if you don't like to draw the picture, which I know a lot of you guys don't like to draw the picture, there is a formula. So the formula goes like this. Cosine of theta is equal to the dot product between the two vectors. So in general, they call them u and v for vectors. And then divided by the magnitude of u times the magnitude of v. And so then you would do inverse. Once you get this number, then you would do inverse cosine. So this always gives you the angle between the two vectors. Formula. So if you like formulas, then you're good to go with this formula for theta between vectors. Okay, you don't have to memorize this. I would give it to you on a test. Okay, so this is really the only way to do it 3D. So I'm going to do another example with 3D. So I'm going to scooch that up, and we're going to do a 3D example, because to draw it in 3D and try to do it, it's just too much. You just cannot do it. So I'm going to use this formula, and I'm going to use, okay, let's say our u is 2, 1, negative 2, and our v, say, is really easy, 1, 1, 1. Of course, I'm going to do an easy example. So I'm going to do the top part of the formula. I'm going to do u, the dot v. And if you recall, that's just multiplying the x components and adding it to multiplying the y components and then adding it to the z components multiplied. So I'm going to go 2 times 1 plus 1 times 1 plus negative 2 times 1. Okay, and that's fairly easy. 2 plus 1 minus 2 is equal to 1. Okay, and then we've got to figure out the magnitude of u. So if you recall that, that's adding the squares all together and taking the square root. So that's 2 squared plus 1 squared, plus negative 2 squared. So doing that, we get the square root of 4 plus 1 plus 4, which is the square root of 9, which is 3. And then we're going to have to multiply that to the magnitude of v, which is 1 squared plus 1 squared plus 1 squared, which is the square root of 3. And we can't simplify that. Okay, now we're going to use our formula. Cosine of theta is equal to u dot v, which was 1, over u times v, which is the magnitude of u, which was 3, and the magnitude of v, which was root 3. Okay, and then now it's time for the calculator, right? So theta is equal to inverse cos 1 over 3 root 3. And if we stick that into a calculator, we get 78.904 degrees. Okay, so pretty easy for the formula. Could you guys see that? Yeah, you could. Awesome. All right, thank you. Good luck.